This is class 5 of the DITA XML class. We are going to make this a recorded session based on events that are happening with the library at Portland State University. Hopefully this session will be helpful, and if you need anything from me, please let me know. So this session is about advanced DITA. These slides are outline the concepts covered in the 5th session. Some of the slides are repeats from earlier sessions, and this is now an asynchronous session based on the events that we talked about earlier. So today you'll have a quiz on DITA fundamentals. That'll be due on Friday at midnight. So you can get that out of the modules, out of Canvas assignments. Go under quiz 2, download that quiz, take the quiz, and then please return it to me anytime before Friday at midnight. Next week we'll have our midterm exam, and everybody should be very prepared for that. Hint, hint, keep your graded quizzes, and hint, hint, pay attention to the slides. So let's jump right into it, advanced DITA. So we have some fundamental knowledge that we've accrued along the way on our road to advanced DITA. We know about XML, what it is, why we care. We know about elements and attributes and well-formed versus valid, and we know about XSL. All of those things come into play when we're talking about the fundamentals of DITA and the advanced DITA as well. We looked at building DITA with topics and DITA maps and images, and then we looked at processing DITA from a fundamentals level. We looked at the command line interface with the DITA Open Toolkit. We looked at our content management system, Hereto. So now we are ready to hit that road to advanced DITA. Now it's time for us to look at some advanced topics like information architecture, content reuse, specialization, graphics and their impact, translation, and best practices. So let's kick it off with information architecture. Information architecture is the establishment of an environment that fosters structured authoring, compliance with business standards, delivery of content in a variety of contexts, and support for multiple media output. This was a quote taken from the reading that you hopefully did, that Joanne Hackos' role of an information architect in the Technical Information Developer World article that we included in our Canvas resources directory. Information architect is responsible for establishing the framework in which consistent, reliable content is produced and delivered to customers, and doing so in a way that promotes the business goals of the organization. So information architecture is pretty interesting. In fact, that's one of the things that several people who take this class kind of gravitate to. There are a lot of duties that the information architect has, and you will have an introduction to some of these duties in this class. But if this resonates with you and you need my help on this, or you want to learn more, please let me know. But basically the duties include investigating, understanding, and articulating customer requirements, defining a business rules optimized for support of customer requirements, modeling metadata, developing standards for content assembly, production, and maintenance, defining a DITA environment optimized to reflect customer requirements, creating DITA structures that support reuse, and creating a usable DITA authoring environment. So one of the things we talk about there is the DITA development environment. Let's take a little closer look at that. The DITA information development environment, there are two aspects to this. The DITA information development environment out of the box is vast, powerful, and complex. So now that we're into this advanced DITA class, let's think about that. It's unimaginable that any one DITA operation would need every feature in DITA. Like I said, DITA is vast. There's a lot to cover there. So removing some of the unneeded complexity improves efficiency. And we're going to take a look at an example on the next slide. The DITA information development environment out of the box sometimes lacks the precision or features that DITA operations require. So that's the other side of the coin. In some cases, there may be some features that really we need to specialize on that aren't out of the box. So the efficiency to reflect on customer requirements can improve, or enhancing to reflect customer requirements can improve efficiency. So let's look at that first one about the out-of-the-box version being vast, powerful, and complex. And let's think about whether removing some unneeded efficiency might help in this particular use case. So here we have a concept, and we're using a DITA-aware authoring tool. And we've put our cursor right there at the end of the first paragraph in con body. And we have all of those elements available at that cursor position. So if you're in an environment, let's say, where elements like required cleanup or syntax diagram or draft comment, for example, are never needed, we might want to simplify this user interface that our authors see so that we don't include all of that noise or complexity. In order to do that, we definitely could hack the DTDs. In our earlier classes, we looked at DTDs, and we understand that those set the rules. However, that's not recommended, because if you hack the DTDs, that would make your DITA environment non-compliant. So if you're exchanging your DITA topics, for example, with a hacked DTD with a DITA-aware translation service, for example, or a DITA-aware publication service, for example, you would put those topics at risk. Instead, modify the DITA information development environment using ways that are supported by the DITA specification. And we're going to look at some of those here. For example, document type shells, constraints, controlled attribute values, and specializations. So we're not going to go into a lot of detail in this class about those supported ways, other than to know that they exist and what they're useful for. There's an appendix on this slide deck that goes into robust detail and specifies exactly how you would do some of these supported modifications. I would be happy if you look at those appendix slides and find anything that you're interested in. I would be more than happy to go over those with you. In earlier classes, we had this as a requirement, and it was, I think it went beyond the introduction to DITA realm. But here they are nonetheless. There's a book that I am quoting this table from. It's the Introduction to DITA, 2nd edition, User Guide to Darwin Information Typing Architecture, including DITA 1.2. Joanne Hackos wrote that book, and the particular table that I'm quoting here is from the 2011 publication by Comtech Services. So you can see this table. If you want to do the things in the left-hand column there, eliminate domains or information types, eliminate elements or attributes, etc., there's a little X in the column regarding the best mechanism to do that. You can use document shells, for example, to eliminate entire domains or information types, or you can use a specialization. As you can see, that specialization column can do all of these things, but there are easier ways. Document type shells can do, as I said, the eliminating domains. Constraint mechanisms can eliminate elements or attributes not needed. As well, they can, constraint mechanisms can make elements required or optional. That can come in handy if you're specializing, or if you have a use case that really requires that. Constraint mechanisms can restrict the occurrence of elements. Constraint mechanisms can restrict or require attributes, and constraint mechanisms, going down to that bottom row, can create new information types. Controlled attribute values can define attribute values for attributes. So hint, hint, this might come up, some questions about this in the midterm exam. You don't need to know how to do these things. You just need to know which of these things can do those particular specializations or modifications. As I said, the details about specializations are not required for this class. The information on how to specialize, how specialization works, is available in the appendix section of this file. This information is not required for this class, but I'd like to make it available for those who would like to know more about specialization. And if that's interesting to you, please let me know, and I'm happy to dive a little deeper on that for you. So let's talk about the next advanced DITA topic around content reuse. There are many ways to reuse content. Content reuse is considered by many to be the most important reason to use DITA, and there are many forms of reuse in DITA. Let's look at a few. Topics can be linked to a variety of different publication maps. We're going to have a slide that illustrates that in just a second. It's reused, and we've seen it a few times before. Topics can be translated into many languages. Topics can be published into many outputs. And elements within topics can be reused via the conref or the keyref functions. So why do we care? DITA enables reuse that can increase efficiency, improve accuracy and consistency, simplify updating, streamline processes, shorten publication cycles, and lower translation costs. So we looked at this diagram before, and we know that, for example, in this simple example, we have a data sheet, a manual, and online help in different colors here, and we see that there is the maps for these simple documents indeed draw upon the same topic. So for example, if I'm looking at the instrument online help and the user manual, I see that the general safety topic is used by both. So it's written once and leveraged twice in this case. So that's an example of reuse. Another example of reuse is translation. Topics can be translated into many languages. So we have our source English topic there in the middle, and then we have Russian, German, traditional Chinese, Korean, Japanese, and simplified Chinese. Another version of reuse is how we can publish it. So we can have that same topic or the same map used to publish PDF, Eclipse, HTML, Online Help, CHM, Java Help, DocBook, or XLIF, and many others. Okay. So topics within, or elements within topics, that could be like a paragraph or a title or a bulleted list or a figure, can be reused via the conref function. The conref function in DITA enables the reuse of content at the DITA topic level. The conref attribute points to a content unit in another topic. The best practice is to have a collection file that contains the standard reusable content. Think about, for example, a file that contains all of the cautions, warnings, and notes, for example, that your company has approved. You can put those in one collection, and then you can just conref those into the desired output. At publication or rendering time, the referenced content appears in place in the topic, and upon updates to the source content, changes ripple to wherever it was referenced automatically. You see a little typo there. I think that if wants to be an it. I'll change that later. As I've said before, unless I make an egregious mistake, I just kind of plow through. Okay, so Here's an example, and I would encourage you to pause this recording and go through these steps yourself. There's an example in the Pareto component content management system. But in this particular file, and I'll show you where this file is in a minute here, we have a conref. So the way you do that is that you select your conref mechanism in Pareto, and you choose the conref content, and then you select a file, and then you can select an element. So in this case, we're selecting something from a specification table. And then you navigate to the collection. So we're going to link inside the file and select the target element. So we've established where we want this conref content to end up. And in this case, we're going to get some company information that we're going to want to put into that topic. So in this particular case, we picked this paragraph relating to the Smith Memorial Student Union, and we're going to reuse that via the conref. And then we're going to notice that once we selected that, it shows up in the place where we published it. And if we take a closer look at the XML, we see that it's indeed a link, not inline content. So we see that that paragraph that says conref, and then it says where the information came from, is what we see in the raw XML. But on the right-hand side there, the WYSIWYG view, we see that it did indeed bring across that Smith Memorial Student Union content. So encourage you to take a look at it in Pareto and see how that all works. So elements within topics can be reused using the keyref function. Note the note down at the bottom there. The keyref function will not be covered in this class, but I'm just going to mention it. The keyref function extends reuse by allowing a single or multiple elements of a given file to be sourced at the time of publication or rendering. The keyref featured consists of two parts. There's a referencing key from the topic where the content will render, and there's a defining key in the single element contained in the referencing key. Again, we don't need to really know how that works, but there is information on that in the appendix if you're interested. Or you can just get with me, and I'd be happy, if this is interesting to you, to go into more detail. Another important reuse in DITA is around graphics. So graphics, traditionally graphics in XML have been linked to bitmap files, and as such the text in the graphics has been inaccessible. Scalable vector graphics, SVG files, are XML files whose text is accessible at the element level. So in DITA you can embed an SVG file via a specialization. Spoiler alert, with DITA 1.3 specification, it actually includes SVG natively. So here's an example of SVG. This is a, as we said before, when a file is a bitmap like a PNG, JPEG, or other formats, the text is not accessible. It's just a bunch of pixels. But in SVG, we have this particular image, and we can look at it in our text editor, and we see that the text is actually in an XML file. And this file actually renders like an image file in the output. But if, as I said, if we look at the text file, it's XML, like so many other examples that we saw. So we see that there are English words here. We can translate those into, in this particular example, German words, and we go through the whole file and do this. Then we save it, and we have a translated SVG file where the text is accessible that can go right into that DITA file. So speaking of translation, this is another advanced DITA topic. We will talk a little bit about it here, introducing translation, but there's a whole session on translation that comes in a few weeks from now. So why are we talking about translation? Well, there's this paradox. DITA's strength is its ability to harness many topics for a variety of outputs. DITA's difficulty for localization service provider is its many files. So we have a strategy to take advantage of the map file in order to manage the many topics. One of the ways we can do that is to create an XSLT that reads the map file and converts each of the referenced files to a single XLIF file. So what is this thing XLIF that we're talking about? XLIF is the XML localization interchange file format. It's an open standard for the exchange of localization/translation content. Translation tools, computer-aided translation tools, use XLIF as the native file format. Translators know and like XLIF. 1.2 was passed February 2008 with a schema and a specification, and then XLIF 2.0 was passed August 2014 with a specification and an XML schema. So why is this important? Well, DITA projects can be very complex. Remember I used that example of the simple data sheet that was printed and then cut into all of its topics. You can have hundreds, thousands, even millions of topics in a DITA project. And yes, I do have, in the interest of eating my own dog food, I have a 1,000 topic DITA project on my laptop here. The LSP can process these topics, but that's not their core competency. They would rightfully charge extra for all of that overhead and expertise. So the DITA adoption technical committee actually put out a recommendation for using XLIF to translate as a best practice. So it's at that URL there. Joanne Hakos, who we mentioned earlier, was the chair of that technical committee. And they came up with this article, they being Joanne, myself, and Rodolfo, which preceded the book that we wrote. And it's available at that URL. And Rodolfo created this really complex workflow. But really what it comes down to is that we start off with our source XML file, in this case DITA, and we have our linked images, in this case SVG, and we use a single XSLT to transform that DITA and those SVG files into a single XLIF document. The localization service provider translate the XLIF files. Then we have the bilingual translated XLIF files, which we transform back into the native file format, which in this case would be DITA and SVG. So if you wanted to look at this in a simplified process map, we start off with the DITA source project. We extract the localizable text information into a single XLIF file. We open that XLIF file with our computer-aided translation software. We save it, and at that point we have a bilingual XLIF file, which we convert back into the existing original format, which in this case is DITA and SVG. So XLIF, the value of XLIF is that it's so simple. What we do in XLIF is we isolate the translatable text in translation units. We call them segments. We have a source for the source language, and then we have a target, which is where we translate the source language into the target language. We retain the source document's structure either internally or externally via the skeleton or group elements. So when we apply that to DITA, in this class, we're actually going to use Swordfish for our DITA translation tool, and that's covered in the video here for the X1 portion of the step-by-step instructions for the deliverables. So I would encourage you to look at that video and to follow along with that video and do the steps. And that will get you some much needed familiarization with how the Swordfish tool works. So I'm not going to demonstrate that in this video. I'm just going to reference the other video and encourage you to go ahead and take a look at that. But the steps are that we would click the open command in Swordfish. We would navigate to the map file, and then we would click open. We would then set our metadata here regarding the source language and target language. If we wanted to use a translation memory or a glossary, we could specify those here. Then we would hit the Translate File button, and it would take the DITA map and pull in all of the DITA topics and then create this single XLIF file. And if we looked at that in the text editor, we could observe that this is the XML that we've been learning about all along. In this case, we just have the source elements in our segments. And then we could either go in manually and translate each of the segments, or we could do the pseudo translate, which is covered in the instructions in that video, or we could use machine translation, we could use AI. There's any number of ways that we could translate these segments. And then we would save that in Swordfish, and we would export it, and we would see that we have our translated elements, and we would have a translated DITA project. And if we look at we see that we have that ZZZ, which is the fictitious Z-ish language that we translated that one particular topic into. Okay, so what's new in DITA 1.3? For years and years and years, DITA 1.2 was very stable and very widely adopted. And then along came DITA 1.3, and it really was kind of revolutionary. It has all of these new features that I've listed here. The ones in bold are the ones that I think are really impactful. Grouping things using div, the key scope, the MathML and SVG natively supported. So if you want to do graphics or equations, rather than inventing a way to do it in DITA or having to use a specialization, it's now supported right out of the box. And then that troubleshooting topic is a pretty big deal. So we went through that pretty quickly. Hopefully you'll have time to do the exercises and take a look at the other video to see the Swordfish section. We do have these appendix slides. They're not required, but they're provided for anybody who would like to learn more about specialization. We go into document type shells, and we have a lot of those, a lot of information on that. And then you can actually do this exercise, and if you choose to do this exercise, it's not required for this class, but I'd be happy to give you some coaching on this. Adopting a DTD. Yeah, there are a lot of steps here, so I won't go through all of these. So that's the overview of the class. Please take your time to go over these slides. I know that this week is a very unique situation because of the library situation at Portland State University. I did this recording as a reaction to that so that we still have the learning that we need to do. It's not ideal, but I think it'll get us through. And then, as I said, please reach out to me with any questions you have. And I will be happy to help you out with that. Okay, so thank you, everybody. That concludes this recording.